Hello, hear me?
Yeah.
Okay. So today we will try to finish up the Unit 3, the programming and algorithm. Okay, we'll go over it. But before we go over it, one thing I would like to talk about is this Moodle part. There is an end of year review. Okay. So starting from the next week, we will have every week. So you click on the AP end of AP CSP end of year review. Okay. And then starting from the next week, that's March 13, 26, we start to work on 3 parents exam. So 1 set per week, 1 set per week, 1 set per week, okay? And then we have 4 sets using the College Board Practice exam, 2016, 16, 18, 20, 21, okay? So these are totally 7 sets. We need 7 weeks to work on it. Especially these college board one. These are the real problems. Okay. And then each set is about 70 problem. And then your AP CSP's exam, multiple choice is 70%. FRQ is 30%. So let's assume that your multiple choice, you got 90%. So your 90% of the 70% will be 63 points. Then you need another 17%, 17 point to get this one got 30 to get a of 80% plus totally. So you need to get at least 70 points, and 17 point, that what that means. This one actually, each problem, each reader give you a score of 1 to 6. Okay, so each value, let's assume that you have 6, then you get 30 points. You have 5, you got 25 points. 4, you got 20. So you need 17. So if you got 90% on here, you will have to have a 4 plus to make a 5 in APCSP. Okay, so if you drop this one, drop down to, let's assume that this one you drop down to 80%. 80% would be 56. Then you need 24. 24 means that you need to have a 5 plus. 5 plus already very hard in FRQ. Okay, so that would be very hard. So if you drop down to 80%, that would be there. You have to make 90% on the multiple choice part. At this moment, I think it will be difficult for you to make 90%. So please get started to practice it. Is that okay?
Yeah.
So the first one will be due next month, Sunday. Okay, the next class. Before class, you need to submit it. You better work on it. So over here, they have a 70 problem. So what I suggest you to do is that work on 20 problem a day. So 20, 20, 20, 20, 10. So you actually will use a whole day to finish them. Don't work on it a single day. You cannot finish it because it will take 3 hours for you to finish it. The first 3 set, the parents said, you need to finish each set within 2 hours. Okay, within 2 hours. The 70 problem, you need to finish it within 2 hours. If you more than 2 hours, then you will have trouble. Okay. And then I don't need you to time it because at the beginning, initially you will be slow. So the first 3 set, the parents said you don't need to time yourself, but the last 4 set, I would suggest you to time yourself, making sure that you finish within 2 hours. Is that okay?
Yeah.
Okay, that's one thing you need to do. Also, when you submit a problem, each is a set, you actually write problem align. So you like return A, B, A, B, C, and then C, A, B, A, B, something like that. Okay. If there is a pick 2, you use a bracket A, B, something like that. Okay. If the some problem you have a pick 2, you write something like this. Bracket A, B, and then Next one, A and B, and another pick two, you actually put B, C inside the bracket, okay? Something like that. So let me show you some student return. This is APCSA, okay, but let me show you some students that return this year. So I just need a file that I don't know who. So let me just actually bring up this. So just need to write something like this. Is okay? So file problem, a space file problem using editor and put it into a text file, txt file. Okay?
Okay.
Something like that. But I do need you to get started already because if you don't do it, our practice would be too late. Okay? Probably. Let me bring up the last year's submission. Let me actually let's do work on some other. Okay, let's look on some 2016 solution. So these are last year's solution. Some students. So this actually five problem, and then when you have a pick two, you write down bracket two, pick two, bracket pick two. Okay, is okay?
Yeah.
Then I will have a program that will automatic grade for you. Okay, but please do work on it. Okay, we need that, and then we will review those problem set as well. So next Sunday class, I need you to submit the first set already before class. Okay, don't wait until after class. If you miss it, then you will pile up a lot of problems. So 1 week a set, 1 week a set. Okay, until the end of the April, you need to finish that. Things get started to get more complicated. Okay, you need to get started. More pressure now. Now, let's go back to work on, continue to work on the algorithm and programming. Okay, these are unit 3. Let's work on it. So this unit 3, first we talk about the app. Okay, the app, and then we work on the algorithm, and we use a code.org to talk about the algorithm, swap, finding the maximum, minimum, those kind of things. And then we also work on the one-page design and multiple page design. Okay, now we go back to theory. We will finish up this lecture 6, 7, 8. Okay, 6A, 6B, 6, 7, and 8 today. Okay, we will try to finish that. And then after that, we will move on to unit 4, computer hardware and network. Okay, network we finished it already because there's a week that we emphasize network, and then we'll go to the unit 5, global impact. Okay, and that's it. Then its AP's content are finished. Now let's go back to this unit 3. So unit 3, we will go back to look at the material for the lecture 6, program structure. So lecture 6 is program structure. Lecture 6B is data structure. Okay. So when we talk about a language, there is a program structure. Program structure means if then else for the decision. So there are 3 types of the program structure. One is decision. One is iteration. Iteration is for loop and the while loop. And third type is function. Function is a subroutine. Okay, these are 3 major program structure. Okay, so this 6A is on program structure, is on program on where you actually your program will go different locations. Okay, that's the program structure. So here we talk about variable data abstraction, mathematical expression, string, Boolean expression, conditionals, and nested conditionals. So these are ifs. Okay. And we also go to talk about calling of the subroutine. So these are functions. So this portion we call it decision. This portion we call it functions. Function also called sub procedures. Okay, also called procedures. So these four phases are the lecture of 6A. Okay, and the iteration this portion is in the 6B or more. Okay. Okay, that's why we will move on today. We'll finish up this lecture 6, 7, 8 together because this portion primarily is on pseudocode. So first one you need to know about available. Available is a memory location to store your variables. Okay, and variable is the name. Okay, right here you may see two kind of things. One is the pseudocode. One is the block expression. Okay. So pseudocode, you use assignment is using arrow, but in Python language, you use equal sign. You use the equal sign for the. You use the equal sign for the assignment. So this one in Python is equal sign, but in pseudocode is backward arrow. Okay. Same thing for block programming. So number one, what is the pseudocode? At the end, what is the pseudocode? You need to know what is pseudocode. When they talk about pseudocode, what is pseudocode?
Like uses English with the program.
Yeah, use English to describe your program. Pseudo means a fake. So it's not real code, it's actually a fake code. Okay. So usually it's using the English-like language to describe your program. We call it pseudocode. Okay. So what is low-level language? At the end, what is low-level language? Hello, hear me?
There's like barely any abstraction.
So what is low-level language? There's no abstraction, yeah, but what is the low-level language? Low-level language have no abstraction or barely any abstraction. That's true. But what is low-level language? Low-level language is machine code. So basically, your binary 0, 1, 1, 0, those kind of things, low-level language. Another low-level language is assembly. So it's the English-like memoric that remember the machine code, so such as move register A to register B. And there's a one-to-one mapping between machine code and assembly. These two things we call it low-level language. Okay. So what is a high-level language? Diana, you need to remember, okay? You cannot study and forget, then you will be in trouble. So what is like high-level language? Talk about anything you know about high-level language.
It's like easy to understand.
Yeah, that's true. What else you know about high-level language? High-level language is human-readable programming language. So it's English-like, but not English, but English-like programming language. So Python, C, C++ is high-level language. is something more readable for human. Okay. So Java, Python, JavaScript, C, C++, they are all high-level languages. Okay, so Python use equal sign. Okay, this one is a pseudocode. This one is the Python, and then data type. Data type usually you test you numbers, string, list, and boolean. Okay, the primitive data type you have integer, string, and boolean. These three types. And numbers divided into floating point and the integer. So what is the difference between floating point and integer?
Like the integers are numbers.
The integers are numbers. So what is the floating point? Numbers.
Like decimal numbers.
No, they are numbers with fractionals. Okay. So string is a collection of the text. Okay. List or array or list is actually a collection of data. So in Python, your index starting from 0, 1, 2, but in pseudocode that APCSP used, the index is starting from 1. Okay, remember that when you test in the APCSP, the index starting from 1, not starting from 0. Data abstraction. Okay. Number 1, what is abstraction?
Like making something not as complex.
Yeah, reduce the complexity of something. So how you reduce the complexity of something?
Like only like just like removing parts that aren't necessary. Are removing parts that aren't necessary?
No, not like that. So abstraction usually means modularized. So what does it mean by modularize? You have two things, two way you will do modularization. First things we call it functional abstraction, or sometimes we call it program abstraction. So program abstraction is that you write a function. Let's assume that you have a function max of A and B, and then this one will return the bigger one of the A and B. So this one we call it program abstraction. Because when you call, you just call this a function. Okay? It's okay?
Yeah.
As for the detail of the function, we already hide it behind you. Okay, we already hide the difficulty behind you. So program abstraction means that you use a function to hide the detail of the implementation of the function so that you don't need to see the implementation of the function. When you call the function, you just need to know about what function name it is, what parameter you have. Then you pass the number into the function, then it's good enough. That's called program abstraction. Data abstraction is the second abstraction. That actually means that it means that you're using an array or you use a string or you use a dictionary, or you use a class to modularize your data. So for example, you have an array of, let's assume that you have array of cars. Then your car may have A, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. So this one will be a car array. So when you call cars, then you have different index. Then you get to the different car. So this car by itself is a data abstraction, and we call it a list or an array, because the cars is a collection of the poker card. Is okay?
Yeah.
So data abstraction means that you use an array, or you use a class, or you use a dictionary in Python. Okay, and class in JavaScript, or those kind of thing, or object. Then you wrap up the data into a object or an array. So we call it data abstraction. So when we pass the data to a function, then the whole array or the whole class being passed over. Okay. Instead of just putting a x and y and pass many parameters to the function, then that will be very difficult to handle. Okay. So those two concepts you need to have. So pseudocode, you will actually assign a list to the A list, and assignment is using backward arrow. Okay. Again, the index starting from 1. Okay. In pseudocode. Okay. In Python, it starts from 0. So these two things you need to remember. Okay. And block language like that. So these things are from College Board. Okay. I just copy the description from the College Board. You need to remember that. Okay. When you see it in the exam, College Board is using pseudocode or block language. Okay. Okay, so they are index and they are elements. Okay. So if you see a bracket, that means that this list is empty. Okay, nothing in there. Okay, if you assign B list to the A list, then A list is pointing to the same array that B list has. These two things share the same data. Okay, is that okay?
Yeah.
Okay, so data abstraction is using containers, just like you have a lunchbox to hide data into the lunchbox. Okay, so your lunchbox may have an egg, some vegetable, and then some rice in your lunchbox. Okay, are you okay?
Yeah.
Okay. That's data abstraction. So, for example, to-do list is actually a array. Okay. Okay. Next one is a mathematical expression. You need to know about the mathematical expression, especially in pseudocode. Okay. So they are sequencing, selection, and iteration. 3 major program structure. Sequencing means a step by step. So you have a step 1, 2, 3, 4, 5, continuing that. That's called sequencing. Selection means that you have yes or no. You need to make decision. Iteration means that you have a for loop or while loop, and you loop back. Okay. So you need to know about the flowchart and also the functions for it. Okay. So sequencing means that you have step 1, step 2, step 3. Okay, step 4. You actually, this is called sequence. Step by step is called sequencing. So mathematical, you have plus, minus, time, division. Okay, and division. Remember that They may have integer division. They may have 14-point division. Okay. If they don't talk about it, usually is this evaluate to the real numbers. Okay. Slash we evaluate to the real numbers. Double slash in Python evaluate to integer. Okay. Mod would take the remainder. So if you have A mod B, this Q will be A divided by B. Okay, double slash is actually integer division. And then the remainder R is actually A get modular by B. Okay, or A mod B. In pseudocode, it uses mod instead of percentage. Okay, percentage is for Python. Okay, you need to know what is modular. So if a number of a number is a multiple of 4, how do you say that? If the number n is a multiple of 4, how do you say that? How do you say a number n is a multiple of 4? It's n mod 4 equals 0. Okay? Is that okay?
Yeah.
Okay, you need to remember that. Okay, otherwise, whenever I ask you, you are not able to answer. That's not good. Okay. String is a collection of the data, and then we do have the slicing, or we call it substring. So you need to remember the slicing rule for Python. Okay, you need to remember that. So, for example, you have 0, 4, 10. What does this mean? If I have a string example in Python, is 0, 10. What does this mean? Like Diana, how does this mean?
Like slicing.
What does this 0, 10
Like,
means?
You start at index 0 but stop before index 10.
10 included or not?
No.
So what does this mean?
Like,
so when I say string underline example 0, 10, what does this mean?
it means it won't like write like index 0 to 9.
So index 0 to 9 means what? Means the first 10 letters. Is that okay?
Yeah.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the first 10 letters. 0, 10 means, so 0, n means the first n letters. Now, how do you say the last 10 letters? So last n letters, how do you say that? If I have a string S, and then how do I say last n letters?
You do like brackets -10 colon.
Colon what? Colon nothing.
Yeah, not just.
So this
just
one
-10.
actually it means the length of S minus 10 colon the length of S. Is that okay?
Yeah.
But this length of S can be omitted. in the Python slicing rule. Okay. Okay. Both the first n later and last n later, you need to know it. Okay. Is okay?
Yeah.
So let's assume that here we do have a 25 laters. I want to get a middle 5 later in the middle. How could I write it? How could I calculate the two numbers? So I have a string of something colon something, and I will get my middle 5 laters. Let's assume the total length is 25. How could I do that? This middle 5, this may be tested in AP, okay? So you need to know.
You do 10 colon 15.
10 colon 15. Are you sure? How do you come up with 10 colon 15?
Because it skips 0 to 9 and it starts at 10 and then
No, that's not the way you should do. Let's assume that you have a number that's 25, that's called n. So when you have odd number, then the middle one right here is n divided by 2. Let's call this n divided by 2 as m, right? So right here, so right now you have the 25, so n divided by 2 should be 12. So index 12 is right here. And then you have m minus 1, m minus 2. So here you have m minus 2 is 10, right? That's actually correct. So it's m minus 2 up to this one and this one. So this one is m plus 1, 2, 3. So this number is m minus 2 up to m plus 3. So m happen to be n divided by 2 is actually 25 divided by 2, that's 12. Is that okay?
Yeah.
You need to remember that. You cannot, because right now we use 25, but this number may change to 27. It may change, okay? You need to be able to calculate the middle 3 or middle 5 laters, okay? If it is a even number, let's look at the even number case. Let's assume that you have 6 different ones. So we have even number, you have 0, 1, 2, 3, 4, 5. So even one, your n divided by 2 is 3. So 3 is the middle one, but the middle on the right. Do you see that? So when even is middle on the right, so you may have middle of this 3, or you may have middle of this 3. That depends on which one you want. Then you need to use the middle one n to calculate a different middle 3. Okay? Is that okay?
Yeah.
Odd case, the the middle one is the n divided by 2. Okay? There's no difference. Even case, the middle n divided by 2 is the middle on the right. Okay, you need to remember it's the middle on the right. Okay, Boolean expressions in the pseudocode, they use the mathematical description. Okay, even though we teach you Python, it's not like that, but pseudocode will use it. Okay. Okay, not, they use not, okay? end, they use end. Okay. Here I just go over the pseudocode. Okay. Or and then or it should be fine. Conditional is the if statements. So here we do have a conditional. Okay. If statement. If this one happened, you go into here. Okay. I think this portion is okay. I don't want to waste too much time. We need to go over other things. If then else, if condition happen, you go into here. If not, you go to the else part. Okay. Nested condition. Nested condition is inside your if. You have another if else. This one you need to know about. You may have the decision strawberry in fridge greater than 7, you greater equal 7, you go to here. Okay, inside here, you actually make another decision. Number of egg greater divided actually equals 12 or not, okay? And then there's a if yes and no here, okay? So your flow chart look like this. Okay, you need to be able to draw the flow chart, making sure you understand it, okay? Next one is a function. Function, you have function call. So function call, you will pass the number to the function. So you have a Python function, you pass the two numbers or into the function and you do processing on it, okay? So function call, you do these parameter and then pass it, and they may have return value, okay? And may have return value. Okay, I think this one's okay. You know how to develop a function, okay? Okay. We finished the 6A. Let's go to the 6B data structure and for loop. You know something, okay, so far I checked you know something, but you are slow in answering. What does this mean? Liana, what does this mean? You do know something, but you kind of, when you answer the question, you are slow. What does this mean? This means you do not have enough practice, okay? Is that okay? Hello, hear me? Hello, Liana, you hear me?
Yeah.
You need to work on more practices, okay? So this is SIG B, we work on iteration, list, and binary search, okay? These are something that covered in. First is a list. So list, you actually have a collection of that, and then you do, in Python, you do index 0, but in the pseudocode, you actually starting from index 1, not index 0, okay? Index 0, we will say index out of bound, okay? We'll say that. So you can assign the element of the i's element to x, okay? Something like that. And you also can get the value to assign to another one, okay? Then you have insert. Insert means that there is a list. So that's assume you have a list 0, 1, 2. That's assume you do insert the A list. Okay, okay. Pseudocode we use 1, 2, 3. Let's use 1, 2, 3. So insert 2 with 4. That means you create a new object before 2. Before 2, if you use index 2, that means before 2, you insert a 4 into that. Is that okay?
Yeah.
So let's assume that you have a list of here, 3 element, index is 1, 2, 3. Then this one is a insert location 0, insert location 1, insert location, I'm sorry, insert location 1, insert location 2, and insert location 3. And after 3 is insert location 4. Okay? Is okay?
Yeah.
So you have 3 elements, then you have 4 insert location. Okay, you have 4 insert location. Append is you have a list. That's assume your index is 1, 2, 3. So append 4 means that after here you create a new node and put the number 4 in there. Okay. Remove I means that's assume you have the index 1, 2, 3. Let's assume you do remove a list 2. That means you take away the index 2, and then you actually go over here. Okay? It's okay?
Yeah.
And when you have this kind of the list problem, you need to draw the diagram in order to help you to understand what happened. Okay? Length of the list means that it's actually calculating how many elements in the list. Okay? So next one is a for loop. For loop, for each element in the loop, for each loop, you will actually take one by one from the list. Okay? There's also possible that you have a repeat n time program. Then this will be run for n times. So this is the same as for variable I equals 0, I less than n, I plus plus in JavaScript. Okay. Repeat n time is the same as this. Repeat until, so here you have a condition A. So condition A happen, you get out of the loop. So that means that if you are here, then we can be sure that condition A already happened. This we call repeat until condition. Okay. For example, if we have A equals 10 right here, and then you do repeat. Okay, let's assume you have A equals 10 right here, and then inside here you have A decrease. Okay. And then your conditions A greater than actually until A less than 5. Okay, so right here you will guarantee A less than 5, so A will be equals 4 when you do this for loop. You use this repeat until loop, okay, because A equals 5, you will continue. You continue because your condition is A less than 5. So when you get out of the loop, means that A less than 5 been met. So you will have A equals 4, okay? So this is repeat until condition. If you do a while loop, so while is while A condition, you do something, and then when you get out of the loop, then that means not A condition will be true, because while A, you will stay in the loop. So when you get out means not A will be met. Okay? It's the opposite of repeat until. So here you have while not toss equal 0. If you get out of while loop, that means that tacos will be equal 0. Only this condition happen. You will get out of the while loop. Okay? Okay, we do have a for loop for each loop. Okay? Return value. So random number return A, B, this is to return you the random number from A to B. Okay, this means that B included. Okay. So random 1, 3 means return, it will return random 1, 2, or 3. Okay, we are done with lecture 6B. Okay, these different problem set. Last time we already reviewed the unit 3 problem set. Okay, so let's have a break. Right now it's 8:45. Let's come back on 8:50. Okay, we have a break. Then we will come back for lecture 7 and 8. Is that okay? Hello, is that okay?
Yeah.
So have a break. 5 minutes. Ariana, I'm back. Hear me?
Yeah.
Okay. Lecture 7 is algorithm and library. Okay. They do have some problem here, so this one is very important. They do have some problem. Last week we already reviewed it, but here let's look at the theory. So what you need to learn right here is the random numbers, how you handle with random numbers. Random numbers, so when you have a random of 1 to 3, let's assume that this one generate A, and then B is random of 2 and 5. So when you have A plus B, the range, that's when this one is C. So C's range will be the largest one plus the largest one. So it would be what? 8. Smaller one is the 1 plus 2. That actually is 3. So your C's range will be from 3 to 8. Is that okay?
Yeah.
So when you have a, let's assume that you have A minus B. So A minus B, A is from 1 to 3. B is from 2 to 5. Okay, let's assume that you actually have the, let's assume that you have the A is the largest one, B is the smallest one, then you will get the largest one. So A minus B would be from -1 up to this one. When you have small, let me see, I'm sorry. The largest one should be A largest one, so it is 3. And then B is smallest one, then you have the maximum. So it's 3 minus 2, you got 1, that's the largest one. And the smallest one would be A smallest, B largest, that would be -4. So it's actually from -4 to 1. That would be the range of A minus B. Is that okay? Hello?
Yeah.
Must remember that, okay? And then algorithm efficiency and undecidable problem. We'll talk about these different topics, okay? So when you learn a language, you need to know about the different program structures, data structures, and then algorithms. Okay, that's what you will study a language, okay? But JavaScript and Python, we usually just teach the orange part, okay, the orange part. So other courses, you need to go to college to learn. So by the way, what is algorithm? In your language, okay, we already defined it here, but what does algorithm really means? Can you describe it?
Like you follow steps to solve a problem.
Yeah, you follow step to solve a problem, but okay, let's assume that you do swap. You do swap A, B. So you say temporary value equals A equals B equals temporary value. This is called swap algorithm. Okay, so your A assigned to temporary value, your B assigned to A, and then temporary value assigned to B. 1, 2, 3 step, you do swap. Okay, so this one, the swap is a problem. And this one is a known solution. A solution that you already studied and know. Is okay? So this kind of known solution, we call it a algorithm. It's a precise sequence of instruction. This is precise means that it already know. We already know that this is 3 steps you do swap. That's already known. This is precise means already known. Somebody already solved it. It's a solved problem that you actually call it algorithm. Is that okay?
Yeah.
So let's assume that you also do swaps. You have swap A and B. So you do C equals A, D equals B, and then A equals D, B equals C. This is called buffer swap. Buffer swap means A assigned to C, C assigned to B, and then B assigned to D, D assigned to A. So eventually B's value assigned to A, A's value assigned to B, but in the middle we use a CD as buffers. So this is another swap algorithm. We call it buffer swap. And in the previous one, using the temp available, we call it rotational swap. Rotational swap means A assigned to temp, B assigned to A, temp assigned to B. You do rotation. Is that okay?
Yeah.
But either way, buffer swap or rotational swap, both will swap. Both are known algorithms. Okay? So algorithm is a precise instruction for process can be executed by computer to solve a problem. So it's a known solution. Somebody already invented, we call it algorithm. Okay? So problem solving, first you need to understand what is the problem. And then you design a solution that we call it algorithm. So sometimes you have already has the swap algorithm you can use. Sometimes you don't. Then you need to invent an algorithm to solve the problem. Okay? And you apply the algorithm to solve the problems to write the program. It's problem solving steps. Okay, this one I don't go into the detail. So what you need to know is this swap algorithm, linear search, rotation and swap, rotation and shift. Okay. Let's assume that you do have a array. Let's look at this one. You do have array. The array data is 3, 4, 3, 4, 5, 6. And I want to do rotation so that it become 4, 5, 6, 3. How can I do it? How can I do such a rotation? I rotate to the left. So 3, 4, 5, 6 will become 4, 5, 6, 3. How can I do this rotation? At the end, how can I do it? This one's in the multiple choice may test it.
You.
So let's assume that, okay, let's put it in JavaScript. Let's assume that A is equal to 3, 4, 5, 6. Let's use a JavaScript, okay? Let's assume let's do variable A equals this. So what can we do? After that, what should we do? Use a JavaScript. What should we do there?
You.
What can I do? The same, again, this one you can do rotational swap. So you shift, so you do variable temp equals A0. I use actually JavaScript, so we do have index 0, okay? You use the pseudocode, you need to use A1, okay? So you assign A0 to temp, right? After that, you do for variable I equals 1, I less than equals less than eta length, and I increase. Okay. So for the 4, 5, 6, what you should do is actually your A of the I minus 1 will be equal to A of the I. You shift from right to left. Eventually, your eta length minus 1 will be equal to 10. Then this would finish the shift. Let's look at it. This one initially, you back up this 3 to a variable 10. Then 4 to 3, 5 to 4, 6 to 5, and then 10 assigned to here. That's 3. So you become 4, 5, 6, 3. Is that okay?
Yeah.
I'm sorry. Okay, let me clear it. Let me write it one more time so I can take a picture on it, okay? So variable A equals 3, 4, 5, 6. The variable temp equals A0. Then for the remaining part, so I equals 1, I less than eta length, I increased. Okay, and then A is I minus 1, the left side one, using the right side one to assign to it. And then at the end, your A's eta length minus 1 will be equal to 10. So this one is the solution for the rotation. You must remember it, okay? You must remember the rotation algorithm because it may be tested. It may be tested, okay? Now again, let's clear it. Let's assume that this time we do have variable A equals, again, is a 3, 4, 5, 6. Now I want to rotate to the right. So rotate to right. So it becomes, after the rotation, it become 6, 3, 4, 5. Okay, how can I do it? So this one you have 3, 4, 5, 6. Now you back up 6 to a temporary value. Then you assign 5 to 6, 4 to 5, 3 to 4. Then you assign temp back to 3. This is called rotational rotation, right rotation. Okay. So to do that, you do variable temp equals a length minus 1, or integer variable I equals 0, I less than a length minus 1, I increase. And then ai plus 1 will be equals a I. At the end, you do a 0 equals 10. This is called rotational swap, rotational of the array to the right. Is that okay? Hello, is that okay? Both right rotation and left rotation may be tested in AP, okay? Are you okay?
Yeah.
Remember how to do rotation, okay? We give you the maximum, minimum, funny maximum, minimum of the array. We also give you the swap. Now we give you the rotation, okay? So you need to download this sheet that we give you, this slides to study, okay? And you need to remember how to do the algorithm, okay? And then linear search. Okay, binary search was skip, okay, too typical. Now, algorithm with efficiency. So you will calculate how many steps needed for a program. And if we formulate that, it will create a function of n, okay, how many steps you will need it, okay? And the function can be 100n, can be 5n squared, can be 2 to the power n, okay? It's different rate. We call them growth rate, okay? So the growth rate, they are growth rate of 1 is a constant time. That means that it's constant time. Log n is actually grow by log n, slowly go up. Okay. Then order n is linear solution. Order n log n is actually slightly longer. N squared is like this. N cube is faster. 2 to the power n is even faster. Okay. It's different time. So usually if it's polynomial time or less, we call it reasonable time. We call it reasonable time. Or sometimes they call it the program is checkable. Is that okay? Checkable. When people say reasonable time, that means a polynomial time. Is that okay?
Yeah.
Then sometimes you need to evaluate the worst case scenario, sometimes the average case scenario. Let's assume that you have an array. You have 0, 1, 2, 3, 4, 5, up to n minus 1. Okay, this is your array. you will want to search if the number A is in there. The best case is the first one you hit it. So it actually is order of one, just one operation you get it. Worst case, if you find n of them, you still don't find it. So it's order of n. On the average, it's actually n divided by 2 because you may be longer, maybe shorter, but on the average, it actually is half. So the algorithm, this linear search, is order of n worst case, order of 2n average case, order of 1 best case. And order n over 2 is also order of n. Sometimes we ignore the multiplication factor. Okay? So ignore the so if you have an an order of an, we drop the a, we just keep the n only. Okay? It's called ignoring the multiplication factor. Ignore the non-dominating factor. So if you have an order of 2n squared plus n, then this n is not important. 2 is ignored. So it will be order n squared. Is that okay?
Yeah.
Constant time we write 1. Okay. So now you have for loop I less than 5. So how much complexity this one is? How can we formulate it? How much time I need? Okay, let's assume that this one takes us C seconds. So totally you run n time of C. So this one is order of Cn. But C is a multiplication factor, so we will drop it. So it becomes order of n. Is that okay?
Yeah.
Does that make sense?
Yeah.
How about this one? How much time needed for this one? Again, let's assume this one it takes C time. So you run outside n times, inside n times. So it's actually Cn squared. C drop. So it's actually it's order of n squared. Is that okay? Does that make sense?
Yeah.
Let's assume right here is 5. This one is also 5. So 5 by 5, you do this one 25 times. Okay? Is that okay?
Yeah.
Previous one, we have no inner loop. So totally 5 times. So it actually is order of n. Now, this one is 1 to n. This one is 1 to I. Then how can you calculate it? So when I equals 1, let's assume I equals 1. J will be from 1 to I, so actually J from 1 to 1. So if I equals 2, then J is 1 and 2. I equals 3, J is 1, 2, 3. So J I equal 4, J is 1, 2, 3, 4. So totally it is, for example, I from 1 to N. This one totally is 1 plus 2 plus 3 up to N. This one is equal to, this one equal to what? 1, 2, 3, 4, 5, 6, 7, 8, 5, 9 to up to N. What is this one? In math, it's called N times N plus 1 divided by 2. So it's the order of half N squared plus half N. So half N drop, half drop is also order of N squared. Is that okay?
Yeah.
Okay? You got to study it, okay? This one. Here, this is 20 now. So totally inner loop, you do 20C. Outside, you do N. So this one is order of 20C. N. 20C drop, so it's the order of N. Okay?
Okay.
Next one, your sequencing. So this portion, let's call it part A. This portion, let's call it part B. So this one finish after that. So this one is the order of 10, because you do 10 times. This one is order of 20n. Okay, so these two in sequences, so totally is 20n plus 10. And 10 drop, 20 drop, so it actually is order of n. When it is in sequence, you combine them together. Is okay?
Yeah.
If you have selection, you do if then else. In two cases, that's actually this case A, this case B. Then the time will be maximum of A and B. Because your A use this much time, B use this much time. If then else, who is longer, depending on who is larger. It's okay because you may go A, you may go B, but the longer one is the one that take longer time. It's okay? Hello, is that okay?
Yeah.
Okay, NP problem. If you can finish it, we call it polynomial time. If you cannot finish in polynomial time, we call it NP problem. Okay, NP problem is a certain set of the problem, we call it NP complete. If your problem is harder than NP, then we call it NP hard. Okay. So right here, P problem, polynomial time problem is anything that you can do, AN square plus BN plus C, anything you can describe in polynomial time, we call it P problem, polynomial time problem. Something that's not polynomial time, we call it NP problem. Harder than the NP complete problem, we call it NP hard, okay? So undecidable problem, there may be some problem that you cannot decide. Even computer can never decide. Now we call it undecidable problem. Okay. There are certain problem that is undecidable problem. So let's assume that there is a barber who will shave people in the city who don't shave himself. Now, so then does the barber shape himself or not? This is undecided. So let's assume that he shaped himself. Then he violated that the barber shape whoever who don't shape himself. If he doesn't shape himself, then he need to shape himself. So this one, whether this barber will shape himself or not, this is an undecidable problem. Is that okay? Can you understand it?
Yeah.
The barber shape people in the city who don't shape him, doesn't shape himself. But if he shape himself, then he violated the rule. He should not shape the barber himself. Okay. If he doesn't shape himself, then he need to shape himself. So this one is a undecidable problem. There are a lot of such kind of problem. We call it undecidable. Undecidable means that using computer, no matter how much time, you will not be able to tell them whether it is true or false, because logically they are conflicting each other. Is that okay?
Yeah.
There are tons of problems that actually is undecidable. So when we see an undecidable, that means that no matter how fast is the computer, you still cannot solve the problem. Okay? State flowchart, you need to understand what is the flowchart. Okay? Okay, you need to know about what is high level language, what is low level language, what's machine code, what's binary. Okay, assembly and lower is called low level language. Okay, we finished the lecture 7. Let's go to the lecture 8 and wrap up today. Okay, number 8, we will talk about bigger project. Okay, so we go through the language for the small component, if then else variables, for the while loop, and then we go to the bigger one for the data abstraction, function abstraction. Then we go to deciding the algorithm, how fast it is. Now we go into the last topic, is a project development. Okay, first thing you need to know about what's project development life cycle. So you do requirement analysis, you do design, you do implementation, you do testing, and then you do maintenance and eval. This we call it SDLC, software development life cycle. Okay, you need to remember that. Okay, and such testing, you need to know about testing. So if you lay out 3 branches, you only test one branch, we call it coverage of 33%. If case A, you do it, case B, you do it, case 3, you do it, we call it 100% coverage. Is that okay?
Yeah.
This will be tested in the FRQ. They may ask you, how are you going to set your variable so you go to this way? How are you going to test your function when you test this way? You need to know how to test branch A or branch B or branch C. Okay? You need to be able to tell people how to set a parameter so you can go to there. So let's assume that you have a program and you say if A greater equals 3 and A less than equals 5. Then when we testing, how many cases we need to test? Let's assume this is 3, this is 5. Then when we test it, how many cases we need to test? if a greater than 3, greater equals 3, and a less than equals 5. Totally, when we create test case, how many cases we need to test? How many? Hello? How could I know how many?
3.
No, you need to test 5 cases. You need to test these 2 cases, 3 and 5 on the boundary. You also need to test the one on this zone, that's 1. On this zone, that's maybe 4. On this zone, it may be 6. So totally 5 cases you need to test. 2 on the boundary, 3 in the zone. It's okay? Any question?
Yeah. No.
When you test and there is a boundary, you need to answer it this way, okay? Okay, library is a people already develop some code for you, and you can call it, we call it software library, okay? Or API. Simulation, okay. What is simulation? So what is simulation? There are 2 words. One word is called emulation. One word is called simulation. So what is emulation? What is simulation? First answer me, what is simulation?
Like creating models
Yes.
to analyze and predict what will happen in the real world.
Yeah. So why we want to do simulation?
To test.
Sometimes the test is dangerous. Sometimes the test case is expensive. Sometimes it kill people. For example, like you do flight simulation for those pilot, then you don't need to fly the airplane to be safe. Is okay? Is okay?
Yeah.
Sometimes the simulation time, the real things will happen like 1,000 years. For example, we want to see the decades of some nuclear radiation. So the half-life cycle is a few thousand years. You cannot really wait until 1,000 years later. So we do simulation to mimic it. Is that okay? So too much time or dangerous or life-threatening, we may use a simulation. So simulation is a mathematical model to predict things. Okay? Is that okay? So can simulation replace the real thing or not? Can your simulation replace the real thing or not? The answer is no, because your model may be too simple. Is that okay? Is that okay?
Yeah.
So if the model too simple, what should you do? For model too simple, what should you do? When the model is too simple, you cannot predict the performance that you want to have. then you need to put more parameter, make the simulation to be more complicated, making sure you still mimic a certain feature you want to know. Is that okay? So if the
Yeah.
model too simple, we make the model more complicated to simulate. Okay. Okay, these are the about simulation. Okay. Hackathon. What is a hackathon? What that is says hackathon?
Like a competition for like collaborating and programming.
Yeah. Usually you have a team to work on. Hackathon is like marathon. So it's actually is the endurance training. So you may have 3 days, no sleep, coding, we call it hackathon. Or 5 days or 1 week coding, no sleep. Keep doing it until you're done. We call it hackathon. Okay. So hackathon, sometimes there's some company will hold a hackathon, so people come in to do the problem solving to find solution, and then within 3 days intensively coding to find a solution. So hackathon is one way to do crowdsourcing. What does it mean by crowdsourcing? What does it mean by crowdsourcing? What is crowdsourcing? Crowdsourcing means that you don't have solution, you don't have a book, you don't have anything else, then you ask internet to see if somebody can give you the solution. Is that okay?
Thank you.
So if there's a company, they are competing with OpenAI, and they don't know how to build a new large language model. So they say, okay, let's hold a hackathon to have all 100 teams to compete to find a solution for large language model. Then that's a crowdsourcing. You source from the crowd. You find a solution from the crowd. We call it crowdsourcing. Is okay?
Yeah.
And hackathon is one way to do crowdsourcing. When you don't have money, you ask money from the internet people. So for example, like GoFundMe, you don't have money to compete in Olympic, or if you don't have money for your son to have a surgery, so you do GoFundMe. GoFundMe is okay. This GoFundMe is also crowdsourcing because you don't have money. You find the money from internet. We call it crowdsourcing. Is that okay? Finding the money from general public. Who will give money? I don't know. Is everybody online? It's okay.
Yeah.
When you have no money or no solution, you ask for unknown people to support you. Then we call it crowdsourcing. Okay. Okay, then we already explained what's a hackathon and what is crowdsourcing. Okay, you need to know that. And when you do hackathon, you do have a team. So when there are 2 people, usually you have 1 driver, 1 navigator. Driver is responsible for coding. Navigator is to find solution and tell the driver how to do coding. Okay. Navigator like the one who actually on the passenger side, and he looked at the map. Driver is the one who handle the handler and drive the car. Okay. And then sometime your hackathon team, you may have a project manager, one domain expert, one UI designer, two front-end, back-end developers. So front-end, back-end developer is the one who do coding. So we have coders, some coder, some project manager, some domain expert. For example, you have a website like doing health, okay, insurance and health. Then the domain expert is the insurance expert. So this domain expert may sometimes don't know about coding. He doesn't know. He doesn't have to know. And there's a UI and UX designer. This one could do it interface. So this one may not do coding, but they actually you beautify the website. Is that okay? So in a team, we need all of these different peoples. Okay? Is that okay?
Yeah.
If you only have 3 people, your project manager may be domain expert and the UI designer as well, 2 coders. If you only have 3 people, so this is not fixed. That only means that 5 roles you need to have, but sometimes you only have 4 people, sometimes you have 3 people. Some people will need to share 2 roles. Okay. For operation, you need to know about collaboration. Okay. And then after the hackathon, you need to do presentation. We call it business pitch. You need to show how your program works and the impact of your program. Okay. Okay, there are website you can look at it. It's called high school hackathons. There are also AI competition. That's also a hackathon called Kiko. Okay. And data open championship, Citadel. Okay, we finished that. Any questions so far?
No.
Okay, so we finished the lectures for the Unit 3, programming and algorithm. Next week, we are moving on to the Unit 4, hardware. We'll talk about computers. And network, we already finished that. So next week, we may finish Unit 4, and we will go over the Unit 4 quiz next week as well, if we have time. If not, the week after the next week, we'll work on the Unit 4. Then we will go to Unit 5. Okay? Any questions so far?
No.
Any question for your school?
No.
Okay, good night then. Bye-bye, okay? Remember next week you need to turn in the first parents diagnostic test, okay?
Yeah.
Okay, good night then. Bye-bye.